Similar triangle review. Remember that triangles are similar if they're the same shape, but they can be different sizes. And we can prove something is similar if they have all the angles congruent and all the sides are proportional. But that's checking a lot of sides and a lot of angles. So mathematicians have some shortcuts if you're talking about triangles, not just any shape. What we found out is if all the sides divide their matching side to make the same number, then they can be considered similar. Or if we have two sides that are proportional and an congruent included angle, the two triangles could be similar. Or if we had two angles. And this is what we learned in section 6b.3. So let's look. It says, show the triangles are similar. So we know that they are. And in looking at it, they gave us a side, an angle, and a side. Same thing over here. So we're trying to show that they're similar by side, angle, side. So first thing, we can say corner A is congruent to corner D, or angle A is congruent to angle D because of those little symbols. And now we need to divide the matching sides. So I'm going to look at 14, and you might say that matches with DF, but notice 14 is the big side, and 13.5 is the slightly smaller side. If you go to the other triangle, 5.6 is the big side, and 5.4 is the smaller side. So big has to go with big. So we could say 14 divided by 5.6, which is 2.5. Okay, and then we could do small divided by small. So 13.5 divided by 5.4. And hey, look, it's also 2.5, which proves they are proportional. They divide to have the same scale factor. And so we could say the pink one, AB, divided by the little pink one, DE, is equal to the distance between A and C divided by the distance between D and F. So they are proportional. So we have proven the triangle ABC is congruent to triangle DEF. And you have to match up. A was the same as D. Okay, B was the same as E, and F was the same as C. Okay, this next one, it looks like maybe they want us to prove angle-angle similarity because they didn't give us any sides. So I look, A is congruent to D because they told us. E is congruent to C because they told us. And if we wanted, we could even say this corner was congruent to this corner because they are vertical angles. But we don't have to have 3 corners, we just need 2 because that forces the third one to be the same. So we're just going to leave these 2 and say triangle AEB is the same as triangle DCB. Again, notice A and D are in the same spot. E has the double lines, and so that's in the same spot as C, and then B and B are the same, so they're together. They have to line up. This third one, we don't know any angles, so we're going to be using side, side, side similarity. And looking at it, we have 2 sides are the same, and a third side that's longer. So the long sides have to match up. So you could divide the short by long or long by short. I like to put the big one on the top. So I'm going to say BC. So BC divided by 1.5, and I'll tell you that's 12. And then if you look at the rest of them, 12 divided by 1 and 12 divided by 1, they're obviously all divided to make 12. So all of those sides are proportional, which is what I've said here. So you can say the 2 triangles, triangle ABC, is similar to triangle EDF by side, side, side. Here's one more. We have 2 triangles on top of each other, and you could actually pull this one out if you wanted to. This is 5, this is 6.25. So here's our triangle, and you could do the red triangle and the pink triangle if you wanted to. This side would be 7. This side would be the 2 little pieces added up, so 8.7. 2.75. 2.5 plus 6.25. And so then we could check. Well, first off, angle A is the same as angle E because they told us. Next, let's check. 7 divided by 5. That's 1.4. And 8.75 divided by 6.25. So this whole side divided by this side. And we also get 1.4. So we have side, angle, side. We can say triangle, the big one, A, B, D is similar to triangle E, C, D by side, angle, side. So those we knew for sure that they were similar. They told us, and we just had to say why. Now they're saying, determine whether they actually are similar, or maybe they aren't. So again, this one looks like side, side, side. So I'm going to match the sides up. Notice this is the large side, middle, small. And then I'm going to go large, middle, small. And I'm going to divide them. Okay, so 18 divided by 12. That'd be the first set. And I will tell you that is 1.5. All right, the middle ones are 12 divided by 8. And that's also 1.5. And then the last one is 9 divided by 6. And I will tell you that is also 1.5. So we could say triangle A, B, C is similar to triangle F, E, D by side, side, side. Because all the sides divide its matching side into the same number. So they all have a scale factor. Again, what does that mean? It means to go from like large to large. If you'd multiplied 12 by 1.5, you'd get the new side. If you wanted to go this way, you could divide by 1.5. All right, this next one looks like it's side, angle, side. So the angles are the same, so we're good. Let's try the sides. 4, 12 is the big one, 4 is the big one. 12 divided by 4 is 3, we're looking good. Oh, 10 divided by 3, that is not 3. That is 3.333. The numbers do not match, so these are not similar. They're not exactly the same shape. Okay? This one, notice that it looks like 6 is the same as 6, 5 is the same as 5, the middle angle. So these not are only similar, they are congruent because they're exactly the same. So we have triangle A, B, C is similar. You could even say that it's congruent to triangle D, E, F by side, angle, side congruence. Or you could just say they were similar because they are the same shape, but they also have to be exactly the same. Please ignore the barking. Okay, let's look at this one. These two kind of look like the same size or same shape, right? We have the outside triangle with a side of 10, 7, and this whole side together is 8. And then we have the inside triangle with a side of 8, 7, and 5. So let's do the big sides first. 10 divided by 8 is 1.25. Okay, and that was the big side. All right, we have the medium side on this one, which would be 8, and the medium side on the little would be 7. So let's see, 8 divided by 7. And that does not work. So these are not similar. All right. So now we know these triangles are similar. So we know this side divided by this side will equal this side divided by this side, and this side divided by this side by definition. So for these, we can just set them up and solve. We could say, okay, this side goes with this side. X matches 6. And then we only need one other pair. So I'm just going to ignore these. Go to this side. 4.5 over 3. And once you have it set up, you can cross multiply. 3 times x is 3x. 6 times 4.5 is 27. Divide both sides by 3, and x equals 9. And then you could check by doing this divided by this will give you the same decimal as this divided by this. Go ahead and try it in your calculator, but it works. Okay, let's look at these two. Well, we have a short side and the matching short side. And then we have this side and its matching side here, which is 4 plus 5, or all of it is 9. So we could say x over 6, and I guess I could color code that for you. Small short over big short equals 4 over 9. And again, it doesn't matter which one you do first as long as they are matched up. 9x. 6 times 4 is 24. Divide both sides by 9. And x equals 2.66666 or 2.67. All right, this last one we can look at a few ways, but I think it's pretty obvious that this side matches up with this side. This side matches up with this side, and the sides that I didn't fill in match up. So I could start out and say, look, this side, x plus 1, matches with 8. So I put them on top, equals. Now I could use this side with the other x if I really wanted to, but it would be simpler just to use numbers. So we did x plus 1 over 8. We did those two. So I'm going to do these two. 12 over 16. I'm going to cross multiply. 16 times x plus 1 equals 8 times 12, which is 96. Divide both sides by 16. And you would get x plus 1. 96 divided by 16 is 6. Minus 1 from both sides, and you would get x equals 5. Now remember, I said you could do that the harder way. So x plus 1 over 8 equals, you could use these two, x plus 4 over 12. And again, that works. You still just cross multiply. 12 times x plus 1 equals 8 times x plus 4. And then this time it's not going to work to divide because we have two numbers in the front. So we're going to distribute. 12x plus 12 equals 8x plus 8 times 4 is 32. If you minus x from both sides, minus 8x from both sides, you would get 12. 4x plus 12 equals 32. Minus 12 from both sides. 4x equals 20. Divide by 4. And x equals 5. So again, it always works out. There are a few other ways to do this as well that some of you have noticed. But as long as you don't break any rules and you set up proper proportions. And again, if x is 5, then 5 plus 1 means this side is actually 6. And 5 plus 4, this side is actually 9. That should prepare you for the quiz. Thank you.